Hello, everyone. So I'm going to start with your notes. So, first off, we're going to start just by practicing graphing lines. So, in your class, we may have talked about y equals mx plus b form. This is our slope. And another way to think of this is your change in y over your change in x. The triangle means change. B is your y-intercept. So that's where it's going to cross the y-axis. So if we look at this, we have our slope is 3, better yet 3 over 1 to think of our change in y over change in x. And our B is negative 5. So I'm going to start by going down to 5 and putting a dot there. Then I'm going to use my slope, my rise over run, my change in y over my change in x. So I'm going to go up 3, 1, 2, 3. And then I'm going to go, 1, 2, 3. And then I'm going to go over 1. Connect the dots, or I could keep making a couple different ones. So 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. You can even go backwards. 1, 2, 3, 1. And then connect them using a ruler. Do as I say, not as I do. Okay, now what about this one? So for this one, if we're doing the same thing, my slope this time is negative 2 over 3. My y-intercept is 2. Now this can be written as negative 2 over positive 3 or 2 over negative 3, whichever way you want. I just typically assign the negative to the top, but it's up to you. So I'm going to go up to 2, put my dot down, and then I'm going to use this one as my thinking one. And so I'm going to go down 2, 1, 2, positive 3, 1, 2, 3. Now notice if I had used this one, what would have happened? I would have gone up 2 and I would have gone back 3. That is exactly the same result. Okay, and then I connect and I call it a day. I put arrows on the end because that line technically goes on both directions. Okay, now what about this one? This one looks like some of the equations we were looking at in class this week, or these past classes, our in-person classes. So if I look at this, this is actually called standard form. Okay. And so for this kind, my suggestion to you is to use intercepts to solve and graph. So what that means is I want to find what y is when x equals 0. And I want to find what x is when y equals 0. Here's what that looks like. So to do the first one, I'm going to plug 0 in for x. And then I solve for y. So then this is 0. Negative 5y equals 15. And if I get y by itself, I'm going to divide both sides by negative 5. And I get y equals negative 3. Cool. There's a point. I get to plot. So I go over 0, down 3. 1, 2, 3. Now if I do the other one, I'm just plugging 0 in for y this time. So I get 3x minus 5 times 0 equals 15. 3x equals 15. Oops, not 15. Sorry. And then if I divide both sides by 3, I get x equals 5. There's another point. 2 points make a line. And so now if I plot that point over 5 up 0, I have a line. Now, once you've used this method, there is another method, okay? And so the other method is I could take our equation and I could rearrange it to get y by itself. So if I look at that, I have y equals, I have 3x minus 5y equals 15. I'm going to keep y over here, and I'm going to subtract 3x from both sides. When I do that, I get negative 5y equals negative 3x plus 15. But I don't want to know what 5y or negative 5y is equal to. I want to know what y is equal to. So I'm going to divide both sides by negative 5. When I do that, I get y equals negative divided by a negative is a positive. And so I get 3/5. And a positive divided by a negative is a negative. Okay. And so this equation and this equation are equivalent. Here are two different ways to do this. If your equation, like up above, is given in y-intercept form, it really makes sense to use that form. Alternatively, if it's given in standard form, you really want to use the characteristics of standard form to graph, and that's intercepts.